So a slightly different way to deal with the calculations that are involved with putting this in vertex form would be always the same. Like you kick this off by looking at these first two terms. We need that x squared to have a 1 coefficient, so the 2's coming out of both those things. And then you could right off the bat put a plus and a minus within the parentheses instead of one in and one out. You know, that's another option. And then we definitely know that half of this square is what we want here, so that's a 25 and a negative 25. But then the thing to kind of keep in mind is that this is the portion that's going to be the perfect square trinomial. So that's going to be the part that I want to leave alone. Yeah, pick it, make it red. Thank you. But this has got to come out of the parentheses. So if I'm going to get that out of the parentheses, I'm just going to take this, you know, it's like kind of a lazy distributive property. So instead of like taking the 2 times the x squared and the 2 times the 10x and 2 times the 25, I don't want to do any of that because I want all that red stuff in there. But that negative 25, it's got to go. So I'm going to end up with 2 times all the stuff I didn't do. And then a negative 50 plus a 48 on the outside. And then based off my work from prior, I know that this is going to be x minus 5 squared with a 2, and then these combine to make negative 2. So however you want to organize your thoughts, totally up to you. But at the end of the day, we need to have an x squared with a 1 coefficient, and we need to have whatever half of this is squared put here, and then the balancing factor put there, and then that has to be taken out of the parentheses. So that's how it should go, and it's going to seem very strange at first, but as you do it more and more, it'll seem oddly comforting.